Hello, this is Mr. Win, and this video is over arithmetic sequences and series. So first, a sequence is just a list of numbers that follows a pattern. So we'll write something like this. It'll be a number, comma another number, comma another number, and it'll keep going all the way till it ends with another number. All right, a subscript 1 is the first term. A sub 2 is the second term, a sub 3 is the third term, a sub 4 will be the fourth term, a sub 5 will be the fifth term, all the way until a sub n, which is the nth term and last term. An arithmetic sequence means that the pattern uses a common difference. That means you're going to add or subtract the same number over and over again. The formula for common difference, D, would be the a sub 2, the second term, minus a sub 1, the first term. And it could actually be any two consecutive terms. It could be the 9th term minus the 8th term, or the 10th term minus the 9th term, or the 5th term minus the 4th term. Here's a short example. We have 2, 6, 10, 14, 18. This is a arithmetic sequence where the common difference D is 6 minus 2, which is 4, because 6 is the second term, minus 2 is the first term. Since it's positive 4, that's really adding. 2 plus 4 gets you 6. 6 plus 4 gets you 10. 10 plus 4 is 14. 14 plus 4 is 18. And that's it. This is a short 2, 4, 5 term list. Here's another example. 7, 5, 3, 1, negative 1, negative 3, negative 5. This is also arithmetic because the common difference D is negative 2. Second minus first. 5 minus 7 gets you negative 2. Negative means subtracting. So 7 minus 2 is 5. 5 minus 2 is 3. 3 minus 2 is 1. 1 minus 2 is negative 1. Negative 1 minus 2 is negative 3. Negative 3 minus 2 is negative 5, and so on. And that list only had, what was that, 7 terms. Here's a non-example. Negative 1, 4, 6, 7, 10, 20. There is no common difference D, so this is not arithmetic. If I try to do second minus first, 4 minus negative 1, that's 5. So negative 1 plus 5 is 4. 4 plus 5 should be 9 next, but 6. So look, it's changing. It's plus 5, plus 2, plus 1, plus 3, plus 10. So that is not a consistent common difference. Now, usually we're always going to try to find the common difference D first. Here's another side fact. If you try to graph this, it will follow a linear graph. So X will be the term number. So the first term, second term, third term, fourth term, fifth term. And I use the same 2, 6, 10, 14, 18 thing. I plot these, I get these 5 dots. And if you had to connect them, it would be a line. All right, now these are actually just separate dots. It's not continuous though. Now sometimes instead of getting a list, you get an explicit formula. If you get that formula, just plug in values of 1, 2, all the way up to n. All right, so here's an example. Determine the first 3 terms and the 10th term of a sub n equals 3 plus 5n. I'm going to plug in n is 1. So where n is, I put a 1 there and a 1 there. So that's going to be a sub 1 is 3 plus 5 times 1. 5 times 1 is 5. 3 plus 5 is 8. I'm going to now do n equals 2. So a sub 2 would be 3 plus 5 times 2. That's 3 plus 10. That's 13. Now I do a sub 3, meaning n is 3. So it'd be 3 plus 5 times 3. That's 3 plus 15. That's 18. And they said the 10th term, so I'll plug in n is 10. So 3 plus 5 times 10. 3 plus 50 is 53. So this list of 10 terms would start with 8, then be 13, then be 18. They'll keep going all the way to 53 as the 10th term. Now there is more in the middle. There's the 4th term, which is 23, the 5th term, 28, and so on. All right. Sometimes you get a list and must find a specific term. There's a formula for that called the nth term formula. Here's what it is. The nth term will be the a sub n is equal to a sub 1 plus n minus 1 times d. A sub 1 is the first term, a sub n is the last term, n is the number of terms, and d is the common difference. You must know 3 of the 4 to use this formula. So here's an example. Find the 50th term of the following arithmetic sequence. It goes negative 21, then negative 13, then negative 5, then 3, and so on, and it keeps going. So we know that the first term, a sub 1, is negative 21. Then the common difference d, we have to find that, calculate it by doing the second minus the first. So negative 13 minus negative 21. We subtract the negative, that's adding. So negative 13 plus 21 is 8. 8 is positive, we're adding. So look, this is negative 21 plus 8 gives you negative 13. Negative 13 plus 8 gives you negative 5. Negative 5 plus 8 gives you 3. 3 plus 8 will be 11. 11 is the next term. But I go all the way to the 50th term. It'd take forever to go one by one. So use the formula. We know n is 50. That's a term number. So we're trying to find a sub n, the last term, which would actually be a sub 50. So when we're plugging into this formula, I'm plugging these 3 numbers in. So 50 goes for n. So a1 is negative 21. N is 50. D is 8. From here, you just type in calculator. Once you plug in all the numbers, you're good. But I'm going to show you the steps one at a time. So I'm going to do 50 minus 1 to get 49. Then I'm going to multiply 49 and 8 to get 392. Then I'll combine terms. to get 371. So the 50th term of this list would be 371. Another vocab word is arithmetic means. Those are the in-between numbers following an arithmetic pattern. And that n-term formula will still help us here as long as you know 3 of the 4. So here's a quick example. Find 3 arithmetic means between -6 and 22. So I know we start at -6. There's going to be 3 blanks, 3 numbers in between, and then 22. So we know a sub 1 is -6, the first term. D, we don't know. We don't know what we're adding or subtracting each time. N is 5, because this is the first, second, third, fourth, fifth term. There's 5 terms. And then the last term, a sub n, which is actually a sub 5 in this case, is 22. We know 3 of the 4 things. So I'm going to plug them into the formula. So here's that. The last term is 22. The first term is -6. The number of terms n is 5. And then we don't know what d is. Simplify this. 5 minus 1 is 4. Then I'm going to move the -6 by adding it to make it 28. Then I divide by 4 to get 7. We now know that d is 7. It's positive, means we're adding. So we're starting with -6. I add 7 to get 1. I add 7 again to get 8. I add 7 again to get 15. And then to check, I'll add 7 one more time. And I get, of course, 22. So the 3 arithmetic means are 1, 8, and 15. That makes us follow an arithmetic pattern sequence. All right, the last thing is a series. A series is the sum of each term in a sequence or list. There's a formula for this as well, called the arithmetic sum formula. And that is S equals N times A1 plus AN all over 2. A1 is still the first term, AN is still the last term, N is still the number of terms, and S is the sum of those terms. So here's an example. Find the sum of the following arithmetic sequence. It starts with 5, then 15, then 25, 35, 45, 55. So really all we're doing is adding those 6 numbers. You could type in a calculator and get 180 pretty fast. But it's not going to be this easy. They could be 50 terms in here, could be 100 terms in there. I've done 1,000 terms in a single problem before. You're not going to type 1,000 numbers in the calculator. You're going to use the formula. It's a lot faster. So here's what we know. The first term is 5. The last term is 55. And the number of terms, 1, 2, 3, 4, 5, 6. There's 6 terms. That's all you need to use this formula. Plug those 3 numbers into this formula. So N is 6. A1 is 5, A and 55. And from here, you just type in calculate because the right side has no variables. I'll do it step by step. 5 plus 55 is 60. 60 times 6 is 360. Then divide by 2, get 180. Done. All right. Sometimes they use both formulas together, the nth term formula and the sum formula. There's only 2 formulas for arithmetic sequences in series, so make sure you know these 2. But here's an example. Find the sum of the following arithmetic sequence. It starts with -14, then -9. It goes on all the way until you stop at 176. So here's what we know. The first term is -14. The common difference d, I have to calculate that. Second minus first. So -9 minus -14. That's really -9 plus 14 gets you 5. Then we know the last term is 176. I don't know how many terms there are. So I must use this nth term formula. I know 3 of the 4 things. So I'm going to plug in 176 for AN, -14 for A1, and I leave alone, and D we know is 5. Distribute the 5 to get 5n minus 5. Combining terms to get -19 plus 5n. Move the 19 over by adding to get 195. Then move the 5 by dividing to get 39. Now that we know there's 39 terms in this list, we can now use the sum formula. We know the first term is -14, the last term is 176, and the number of terms is 39. So those 3 numbers will go into this formula. 39 times -14 plus 176 all over 2. Again, you can just type in the calculator and be done, but if you want to show the next 3 steps, you can. I'm going to do the inside to get 162, then I multiply to get 6,018, then I divide by 2 to get 3,159. So if you add all 39 terms in this list one at a time, that's a lot of typing calculator, you will get 3,159. All right, the last slide is something called sigma notation. This is a shortcut or shorthand way to write a series. You're going to see this E symbol. That's called the summation symbol. That's the sigma itself. And it tells you to add everything up. So it's a series. Then on the bottom, you're going to have this K equals a number, or I equals a number, N equals a number. It's whatever the letter is, and it tells you what's the first value of the variable to plug in. The thing on top will be the final value, the last value of that letter to plug in. And this thing on the right side will be the equation you use, the explicit formula, to plug in those values of K. So here's the problem. Find the sum of the following arithmetic series. So the summation of 3k plus 2 from 4 to 9 is how you read that. So option A will be find every term of the sequence by plugging in k as 4, then next will be 5, then 6, then 7, then 8, then 9, and add those terms up. If I plug in 4 into this equation, 3 times 4 plus 2, that's 14. Plug in 5 to that equation, 3 times 5 plus 2 is 17, then 20, 23, 26, 29. So there's 6 terms here. I could add all 6 up to get 129. Now again, that's usually not going to be helpful because this is too short of a problem. It's going to be a lot longer. So do this formula. Here's the full way of doing it. It's actually faster. You can use that sum formula. And to use the formula, you just need 3 things. The first term, the last term, and the number of terms. To find the first term, plug in k equals 4. We used to get 14. To find the last term, plug in k as 9 to get 29. I don't care about these middle numbers. Then to find the number of terms n, all you do is top minus bottom plus 1. So that would be this 9 minus 4 plus 1. So 9 minus 4 is 5 plus 1. This should be a 6. All right. A lot of kids think from 4 to 9 is 5 terms. No, it's 6 terms. That's why you have to do that plus 1. These 3 numbers go into that formula. So I plug in 6 for n, 14 for a1, 29 for an, all over 2. And I'm going to type on the calculator. I'm not going to do it step by step. And I get 129. And that's it. That's everything about arithmetic sequences and series. If you have any questions, make sure you ask the class. Thanks for watching. Bye.